Okay, welcome back. I think this stream should be working now. Yep. Right. Um, so welcome back to day 5 of Advent of Code. Um, same format as always. I haven't looked at this. I haven't started any programming. I haven't looked at the task. And we'll see if we can't solve this. So let's just jump right in. Day 5, hydrothermal venture. You come across a field of hydrothermal vents. So these are like underground volcanoes in a way, I guess. Yeah. Well, okay. Kinda. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. Right, because we're driving around in a submarine. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents, which is our puzzle input. Ooh. Maybe they're Bressenham vents. So this is something that Advent of Code does. It just randomly adds in these highlight things for words in the text sometimes. So if you see when I'm reading, I often scroll my cursor across, and it's to find these things. Bressenham vents. Let's see what that is. Bressenham's line algorithm. Interesting. Aha. Right. So, a pretty standard line drawing algorithm, it seems. Anyways. Yeah, so that's our puzzle input. For example, 09 to 59, 80 to 08, 94 to 34. And each line of vents is given as a line segment in the format x1, y1 to x2, y2. Right, so this is like a line drawn from 09 to 59. Or I guess it would be 59. And from 80 to 08. So x, y to 08, which would be down that way. Yeah, where x1, y1 are the coordinates of one end of the line segment, and x2, y2 are the coordinates of the other end. These line segments include the points at both ends. Right, so they include these starting and end points. In other words, an entry like 1113 covers points 11, 12, and 13. 97 to 77 covers point 97, 87, and 77. That makes sense? For now, only consider horizontal lines and vertical lines. Lines where either x1 equals x2 or y1 equals y2. Right. So the horizontal and vertical lines from the above list would produce the following diagram. So these are, I'm not sure what the twos are here, but these are the lines from above. In this diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point, or a dot. Right. So apparently there's a line segment there, which covers just a single point. Not quite sure what that would be. Maybe it's this one. No, that's this one. So that would be 0, 1, 2, 3, 4 in the y direction, and 0, 1, 2, 3. So it should be 3, 4 to 1, 4. Ah, right, so there's one line going this way, and there's one line going this way. That's why there's a 2 there. That makes sense. Okay. Right, so the number of lines which cover that point, or a dot, if no line, yeah, a dot if no line covers that point. The top left pair of ones, for example, comes from 2, 2, 2, 1, which are these two. The very bottom row is formed by the overlapping lines 0, 9 to 5, 9 and 0, 9 to 2, 9. So this segment right there. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. So this point, and these 3. Consider only horizontal and vertical lines. How many points do at least 2 lines overlap? Okay, so we can get our puzzle input, which looks like this. So this is obviously quite a bit larger than our input, or than our example. But they all seem to be sort of less than 1,000. I'm always a bit conflicted, like when I write these, if I should look at the input data and sort of code to my input data, or if I should write them super generic. So in this case, for example, I could do an array, like if we just wanted to like make this thing, I could do an array of 1,000 by 1,000 positions that would cover my entire input space, but it wouldn't cover sort of any input space. I mean, these are generated by some rule, so they do have some input space, but they're not necessarily a it might not be obvious looking at my input what the generic input is. Right. I'm also going to open here. This is something I've been doing. So we're going to keep this as input example. So now we have the example input from our code here. So this is pretty simple. It's a number followed by a comma followed by a number. Of course, these are single digits, but if we look at the actual input, we can see that these are any number and they're not like 0 prefixed. So we need to parse in a number, a comma, a number, a line, a number, a comma, and a new number. There are a couple of ways we could do this. One way is the simple like split on this character. That gives us two sort of pairs of numbers, and then we can split on the comma and then parse out these two. We could also use something like scan tuple from this module, where we basically give sort of inputs, we give an input format, and that gives us out a tuple of stuff. So I think we're actually going to try this. I haven't really used scan p a lot, but I kind of want to try that. So if we import the string scans module, and then we do for line in lines, and I've been writing these as like this to iterate over the lines in a file. We could also do this, or even I believe like that. Yeah, So this is part of what is called the unified function call syntax, and that is probably a bit gray. String scans is based for AoC problems. Yeah, a lot of AoC problems can be solved with string scans. It's pretty nifty little module. Once we get further, I kind of want to look at npeg that I've been using in the past for these. But this is still so simple that we'll go for a simpler solution. So this is part of the universal function call syntax. That means we can call functions in many different ways. But I think we can also actually call it like this. No. Maybe if I do this actually. No. Right. I parsed that as a tuple. So you can pass blocks of code like that, but I'm apparently not normal arguments. Anyways, so we have a start x, start y, a stop x, and a stop y is equal to if we look at our scan tuple procedure here. Scan tuple, you do this is equal to scan tuple, and then you give it a format, or you give it an input string and a format. So we want to give it the scan tuple. We want to give it the input string, that is the line we just read in, and the format is going to be, I believe, just $i for our numbers. If you look here, $i decimal integer uses %, which is probably what we want. Right. So we do $i, comma, and now we need to watch our spaces. So there's no space there. Comma, $i, space, arrow, space, $i, comma, $i, again without a space. And now we can echo these out just to check that we have sort of wrapped everything correctly. Just make sure that we have parsed everything correctly here. Stop x, stop y, something like that. Okay, it immediately has a complaint for us. Wrong number of variables. We do have 4 things here, and we do give it 4 variables. Pattern is a static string. Matcher type, that is just probably if we want to do something with our type. So we're at success. Oh, right, success. So the first element in the tuple is always going to be a Boolean called success. So if success, so that is just if it managed to parse this line as this format. Otherwise echo bad parsing, for example. There we go. So if you have a look at this, now it parses them out, and we can use these in our code. and those look correct. Just double check that it actually parses my whole input set. Right, it appears to work fine for the actual input as well. So that format is good. And now, so we only want to do horizontal and vertical lines, meaning x1 is equal to x2 or y1 is equal to y2. So let's, in our success branch, actually let's do, if not success, just quit the program. So we don't need, we don't have to nest everything. If this was an actual program, we would probably throw a parsing exception here, or maybe log an error or something like that. Right, so we want to check if we have a horizontal line, which is if start x is equal to stop x. Horizontal, and do the same thing for our y here, and do vertical. So now we can see our 9434, our 2221, these are in fact mapped correctly. That's good. And now we need to count our things. So as I said, when I'm doing these, I'm not sure if I want to do something that works for any input, or like only the input we're given. In this case, we only have like a small board for this test input, but a larger board for our actual puzzle input. And I think what I'm actually gonna do here, because we're basically only interested in these counts. We don't really care where they are as of right now. So what we can use in nim is a count table from the tables module. And what a count table is, it's useful for counting the number of items of some container. So if I define counts is a count table of tuple x, y, int, for example, now I have a table that will count the frequencies of xy tuples, which is basically what we want. And this means that, for example, this large empty area here is not going to enter into our table at all, which is pretty neat. So here, if the start x and stop x are the same, we're gonna do for x in, for y in start x, or start y dot stop y. This will not work. I'll get back to that later. So counts, unlike normal tables, have a slightly different, it has a slightly different insertion. Like a normal table, you would do something like this. You would access it with this and like set it to something. A count table, on the other hand, would use this increment thing. So we want to increment the tuple start x, which is equal to stop x, and then the y. So that is our xy tuple. And note that I added a space here. That is the same as doing this, which is again the same thing we were doing up here with the universal function call syntax. So this space here does the same work as that space there. And now these are not arguments, but they are, it's a tuple definition. Let's see. Oh, we of course need to import the tables module for our count table to work. But yeah, as I said, this won't work because in our example here, if we look at, so now we're doing horizontal lines. So that one will work. This one here won't work. So, oh, that is actually not a horizontal one. Right, so both of these will, no, this won't work. So we can't go with a normal dot dot iterator. We can't go from a large number to a small number. But the order of these don't really matter. So what we're going to do here, we're going to say the smallest one of start y and stop y, loop all the way to the biggest one of start y, stop y. So this is going to pick the smaller number, this is going to pick the bigger number, and dot dot looping is inclusive in them, so we're going to loop from this up to and including this one. So that should work. If we now echo out our counts at the end of the loop here, we can see for our horizontals we have 2 2 is 1, and 7 3 yeah, 2 2 is 1, 2 1 is 1, 7 0, so 7 3, 7 4, 7 2, 7 0, and 7 1 are all 1. And those are the only two horizontal lines that we have. So that appears to work fine. So I'm going to remove that. And then we basically want to do the same thing, but opposite for our y value here. So I'm just going to replace the y, a small y with a small x. And I'm going to replace a capital Y with a capital X. And that should essentially, this has to be a Y, of course. So that should work. So when start Y is equal to stop Y, we loop over the X values, which are now the only ones that are different. And then we add that as our count. And now we should see that our count table, if we count the 2's here, the 1 2 there for position 4 3. So position 0 1 2 3 and 0 1 2 3 4. So that is 3 4. Wait, X. That is not correct. But let's see, do we have 5 here? 1, 2, 3, 4, right. So we apparently don't have 5. Ah, right, of course, this should be X and start Y. So when I copied this down here, I flipped the order. This should be correct. Yeah, so x3, y4 has 2. X is 1, y equals 9. That is this one. 0, 9 is 2. That is this position right there. We have 7 x7 y4, which is this one. And we're gonna see, yeah, 2, 9. Yeah, and that's all of them. So now all we need to do is to loop through the results of our order table or our count table and get out the numbers that are bigger than 2 and count them. Let's see. So we could actually do this. We only care about the ones that are higher than 2. So as soon as they become 2, we can count them. I mean, for these, we only have 2s, but for others, we might have something more. So if we do here, right. So these are the ones with many vents, spots with many vents, starts at 0. If counts start x y is equal to 2, increment the spots with many vents, do the same down here. And this is a bit like now we're repeating ourselves, which isn't great. If we now echo out our many vents down there, we can see that that outputs 5, which is nice. We can remove this echo, we can remove this echo, and we can write a small template here, which says count spots, which takes an x and a y as an integer, doesn't return anything, and does this thing, which creates that xy tuple and checks if that xy tuple is equals to 2 and increments that. So now we can do something which is slightly nicer, count spot, and this was start x and y. And down here we can do x and start y, like that. Of course, we could have created one that took these as well. So we could have one called count spots, which takes start x and stop x and does that logic as well. Let's not do that right now. I just wanted to give a small example of how a template can take even like simple stuff like this. It's not always about doing crazy macro magic, just doing simple stuff like this. And we could throw this in a procedure as well. In fact, since these two are globals, this can just be a procedure if we want to. It will work exactly the same way. But as a template, is basically just means the same as copying it out. And the C compiler might inline this anyways, so it might actually copy this code into here and into here manually, but maybe not. Or not manually, automatically. Okay, so if we now run this with our actual input, we should have the result for our first puzzle. Hooray! So now we're one gold star closer to finding the sleigh keys. Part 2. So I assume this one now includes diagonals. Yeah, unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You need to also consider diagonal lines. Because of the limits of the hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or a diagonal line at exactly 45 degrees. Well, that's great. That simplifies things significantly. In other words, an entry like 1133 covers points 11, 22, and 33. An entry like 9779 covers points 9788 and 79. Considering all lines from the above example, we now produce the following diagram. So this is the same as this diagram, but also with diagonal lines. So you still need to determine the number of points where at least two lines overlap. In the above example, this is still anywhere in the diagram with a 2 or larger, now a total of 12 points. Right, so now we need to do diagonal lines. This exactly 45 degrees greatly simplifies stuff. So as you can see here, we basically just need to always iterate up both our variables, or up or down, depending on the direction. So we only need to step, like we step the variable once up or down, both x, y pair every loop, and we get our line. If you go back to looking at the what do they call them? Bressenham stuff. If it didn't have that 45 degree thing, you can see here we would sometimes have to go over 1 without going down 1, and similarly like over 3 and down 1, and similarly we might have to go like down 2 without going over 1, and that just complicates the math. We also need to handle cases like this, like is this point there or is it just not present, and stuff like that, which is just way more complicated than 45 degree lines. So that's a nice little simplification. So basically we now need to start with a pair, figure out if we need to go like plus minus or minus plus or whatever, and then apply that transformation once every step until our values are match up with the end result. And let me just copy part 1 over to part 2 so that we can build on our existing result here. There we go. So actually, this means that this bit of our code can now go. And we need to figure out, so now we're just going to write a generic one. And I'm thinking we do this as just create a transformation. And this might not be the most efficient way of doing this, but basically what I want to do is I want to create a transformation that is either 1, 1, 1 minus 1, 1, 0, or like 0, minus 1, 0, stuff like this. And that is just going to be added to our start x, stop x tuple every time to advance the line in the direction that we need to go. I'm just going to do this in a block, I think. We're going to say, well, maybe not a block. So start x can be either 1, minus 1, or 0, depending on 3 cases. So we say x is equal to a case. actually we can't use a case for that. If start x is equal to stop x, and let's just do that on a new line and do that on a new line. So if start x is equal to stop x, then it's 0 because it doesn't have any speed at all. Otherwise, if start x is greater than stop x, that means that we start further down than our end position, which means that we need to, in x. So we start further to the right in our image. I need to go left, so that means we have a -1, or we just have a 1. Then we do the same thing for our y, just obviously with by replacing x with y in these equations. And that should now give me a transformation. So if I now look at the transformation, no, do not overwrite. If you now run this and look at the outputs, let's go back to look at the example so we don't have so many lines. If we look at this, so this one is the first line. If you look at our example input, that means so 0 going from 0,9 to 5,9. So that is a vertical line from x0 to x5. That would be a horizontal line. A horizontal line that goes from 0 to 5, which is +1 and no movement on the y-axis. This one should go to the left. I hope my camera is still flipped, by the way, because I'm drawing these. I'm pointing. Yeah, looks good. So, like I'm pointing to my right because the camera is flipped. So -1, this should be going left, and it should be going down because y increases. So x is 0, yeah. So that is moving to the left, and this one is moving down. Okay, so this transformation stuff seems to work. So now we can do, we can say x is equal to start x, y is equal to start y, while start x is not equal to stop x. And since we can only have like vertical, horizontal, or 45-degree angles, these won't ever like we will never run into a case where we reach our x position before we reach our y position, or vice versa. So we only need to check one of these. So while these are not the same, now we need to make sure that we actually get both of them. Like we need to get our start position and our stop position. So I'm gonna actually count the spot of start x and stop and start y before I start looping. And then start x plus equals transformation.x, and start y plus equals transformation.y. This is another other thing. Like the variable is named int. Oh, x, of course, not our start x. Yeah, now I can't show what I was going to show, but stop x is defined to have a capital X. In nim is case and underscore insensitive, so I could type stop x here and the code would work just fine. I could also write stop underscore x and it would work just fine. This is something that people tend to freak out about because they think it's going to lead to horrible unreadable code. In reality, it means that you can prefer underscores and write the module with using underscores, and I can import that module in my code and use camel casing, and I end up with a uniform code base. So I used to use Python before I started using NIM, and in Python you would find libraries, some of which use camel case and some of which use snake case. And snake case, like the library that, or the code that I wrote, then ends up having a mix if I import two libraries with differing styles. But in NIM, I can import libraries with differing styles, but I can still write my code in whichever style I prefer. So the arguments against this kind of stuff is exactly the same arguments that we use for it, because it really makes my code more coherent than less. Of course, I could do this, but in reality, no one does. I mean, sometimes you might miss a capitalization. That has happened to me. And then, like, the simple search and replace doesn't work. But since this is a compiled language, the compiler will just scream at you. Or the compiler wouldn't scream at you because they're the same. But if I refactor something and I forgot to rename a variable, it would probably become obvious real quick. And if I find code that has one variable called stop x and one variable called stop x, I'm gonna stay away from that code base. That is not good design. The sort of the only thing that we have the first character is case sensitive, so that we can write count table, and this could be called count table. But that is sort of just because that is an object-oriented paradigm that we want to support. But that is the only exception. Anyways, yeah. So we loop over all of these, and then we want to count the spot at start x, or of x and y. So now start x, that should of course be x, not start x. So as long as x is not equal to stop y, it runs another loop, then it adds these, then it counts this, and then it stops, like it doesn't go another one over the stop x. This is something that you could do with a do while loop, but we don't have those in NIM, so too bad for us. We can't write them with a macro. Right, so that gave me 9, which is not the number we were looking for. Like with our example, it should be 12, but we only got 9. I wonder why. Is it because of this? It shouldn't be. And we do x and y. That is a bit weird. So let's echo out our transformation. And let's just quit after running 1. So we only do the first line. And I want to see the count for the first line. Right, so that is 1 0. The first line in this test input is this 0 9 to 5 9. So we should have 0 9 1 9 2 9 all the way up to 5 9. 1 9 4 9 0 9 5 9 2 9 and 3 9. So that seems correct. So don't quit. this will be a bit noisy output, but so for the second line, that should give me 80 to 08, which is a diagonal line, which should produce 80, 71, 62, so on. So 17, yeah, 17, 19 is from here. 44, I guess. 26, yes. 4980 should be in there. You know what? Let's actually draw this out real quick. So for x in for y in 0.8, for x in 0.8, because our test grid here is this is a 9x9 grid, even though it doesn't look like it because it's taller than it's wide. And we're gonna do, for this, we're gonna do standard out as right, not right line. If counts x, y is equal to 0, we output a dot. Otherwise, we output the counts x and y. And then for every line, we just write out a new line character. Just convert that to a string. So of course, if any of the counts go over 10 or over 9, this will break and look weird, but it shouldn't. So now we can compare this to this. 101, that looks good. Right. We have 4 spaces there. We have 4 spaces there. Oh, it's a 10x10 grid. Yeah, it's the positions 0 through 9. And that looks better. Right, so we're missing one there. And we're missing one there and there. So we are missing a couple. This one renders out fine. These look fine. That is fine. 1, 1, 2, 3, 1, 3. And this should be a 2. So we seem to be just missing a line there. And we're missing one spot there. Otherwise, it looks good. That is really strange. Are those? Yeah, so this spot there should have been created by the first line. No, by the this line. But it did not. It didn't. In our code, it didn't write this position. So it seems like we're losing like a start one or something. Is this actually? Oh, right, of course. So as long as x is not equal to this and y is not equal to stop y, because now when we were doing these lines, it would just quit immediately because it wasn't moving along the x-axis anymore, but it wasn't supposed to because it was a 0. So what I said before only holds for the diagonal lines. Oops, that seems to have made stuff worse. Because this is not that's supposed to be an or. I'm not thinking about this logic. I'm just, yeah, there we go. I wasn't thinking about the logic there. I was just trying stuff. Yeah, so now we see we're drawing this thing, and this line seems to now be filled in as it should be. And we get the correct 12 as a result. Pretty good. I kind of want to see the result of our big one. So I'm going to print out this thing anyways. So now we should be able to just go to our actual input and run it. And of course, our we can input this first. Yay! That's the right answer. So we're 1 gold star closer to finding the sleigh keys. Nice. Ooh, and now we have hot vents. Oh, so this is a vent, and this is the steam coming off from that vent. That's pretty cool. So yeah, as you can see, it colors it in as you go. So before you do one, you don't see any color, and you sort of don't get the full resolution. But as you progress, it will give you more and more details, which is pretty cool. So you can see this one is pretty detailed. But if I go to a year that I haven't done, let's see. If I go to a year that I haven't done, I didn't do 2019. You can see it's just, there's no colors, there's no detail in this. Yeah, that was the solution. But I still want to see this map. But I don't think my terminal is actually 1,000 characters wide, so this will likely wrap. And yeah, so like this is one line, which looks pretty ugly. Yeah. That doesn't look great. But you can see here how much empty, like how much space that doesn't have any dots. This is stuff that we would have stored in memory if we had just done it with an array. Just keeping the counts by position, we don't have to keep track of all the empty spots on the map. Might be faster, and for some inputs data, it might also use less memory. But this is this supports any width, as long as it's in the int input space. But int in NIM, when you're running it on a 64-bit machine, it's a 64-bit integers. So this would be, what is it, like a couple quintillion numbers. So any input set within reason, we should be good with this code. I'm still a bit bummed that we can't have an output, like look at the output properly. We could do something with drawil. Oops. So I implemented, this is a Python library, but I implemented it for NIM as well. This uses UTF-8 Braille characters, which are basically, it's a 2x4 set of dots, and some of these aren't even valid Braille. They just figured out, hey, let's just add all of them. And that means that people can do stuff like this, where you, in your terminal, you can say, well, I want to draw, like, these are characters that are composed of sub-character sized dots. So you have a higher resolution than you would normally have. I think I have some example code in, let's reuse this terminal. I should have some examples in Droil. Yeah, here. So I run the example. This is pretty much the same thing as this one. Oh, my implementation. Yeah, my implementation is listed on the official Droil site. That's cool. So yeah, this one I also implemented collision. So you can see that this flashes to true when something collides with that spot. I also have a concept of layers, which, like, it doesn't look that different in code, or it doesn't. The output doesn't look that different, but the code uses layers, which makes the drawing a bit easier. And I also have a game of life, which uses colors. Now you have colored game of life dots floating around the screen. And this is probably freaking out the compression algorithm for the video. And yeah, so I implemented this, but like, you can save this as an image, you can load images, stuff like that. And it just plays game of life. Which is pretty cool. And surprisingly, like, it keeps color values for each pixel, and it calculates the color. So a character is still, you can see when I highlight stuff, characters are still the same size as normal characters, but they have dots sort of within them. And the colors are calculated by making like an average color of all dots in one character, which makes the blending surprisingly smooth, actually. It's pretty cool. It's pretty cool the way that works. And they are each, I don't remember how I actually made this. I guess each particle somehow has color, and when it creates a new one, I guess it uses the same color or something, or the average of colors of the input characters or something like that. So yeah, that's not related to the advent of code stuff at all, but we could probably implement some sort of display for this based on that. Or of course we could implement something with like cursors moving it back and forth. But we're not going to do that. Again, if you want to see other advent of code solutions, you can check out this advent of NIM, advent of code thread on the forums. And this guy, Pietro Peter, I don't know how he pronounces his handle, has started doing, oh, right, so he actually generates music from, it generates music from the input data somehow. I think he also generates some graphics. Doesn't seem like it. I know that some people tend to, oh yeah, here he made a nice little graph. And graphs out some of the data. So maybe he will do a nice visual representation of all of them. But I'm not going to do that, at least not on stream. Yeah, that's it for day 5. This was, again, not super complicated, but it has a bit of that, like, you can do it easily. Like, you can just create a 1000 by 1000 array and just count the pixels in the array. Or you can do something like I did and create a table so we can support any size of input, stuff like that. And also this, like how you move through X and Y space based on coordinates might be a bit tricky. I went for maybe a not super conventional way of doing it. But it certainly is one way of doing it, and it works. I could, of course, instead of having created a tuple, I could have created a transformation X and a transformation Y variable. But I wanted to show off how you can, in Nim, create an immutable variable that is a tuple from if statements. Like it would be very easy to write this as like tx equals 0, and then say if start x equals stop x. Well, then it wouldn't have to do anything, but if start x is greater than stop x, then tx is equal to -1, and do this, then it's 1. But then tx would be mutable, and if we by accident sort of said, for example, tx down here, by accident, it wouldn't, like we would have an error. But now, since this is a immutable variable, we can't change transformation x after we generate it up here. After we create it, it's immutable. Same with like start x and start y. That's why I got the error initially. Like if I type start x here, I'm gonna get an error saying like, ooh, I got integer and integer, but I expected for the plus equals procedure, I expected a variable t and a t. First type mismatch at position 1. So this one variable t is not variable. Start x is not variable. It's not mutable. This is an immutable value, so we can't call the plus equals function on it. So yeah. Of course, plus equals is just a normal procedure. We could even call it like this. We could do that and call the plus equals procedure like that, or we could even do it like this, and call the plus equals function with these two arguments. But this is another, if it qualifies as an operator, meaning the name is composed of only a handful of symbols, which are defined in a list in the systems module. I think it's in systems. Operator. Yeah. Then allows user-defined operators, and an operator is any combination of the following characters. So if the name of a procedure is only a combination of these characters, so plus equals would qualify, then it is an operator. Operators can be called like this, which is pretty neat. Yeah, that's it for day 5 of Advent of Code. Hope you found this interesting, and hopefully I'll see you in one of the other days.